Welcome back to the Mechanics of Solids lecture series. In this series of videos, we're looking at examples using Mohrs circle. The next example, we have two different cases of plane stress, and for those two cases, we're asked to determine the maximum in-plane shear stress and the overall maximum shear stress in any plane using Mohrs circle concepts. So we're going to think a little bit beyond the plane stress state and to what would happen in 3D. Okay, so let's start very simply, not going to worry about the stress state so much, but plotting Mohrs circle for both of these two cases. And in order to do that, I need to know the center of the circle and I need to know the radius. So I'll remind myself of the equations. A equals sigma x plus sigma y over 2 is the center of the circle, and the radius equals the square root of sigma x minus sigma y over 2 squared plus tau xy squared. So we'll use both of those equations. For case 1, the center of the circle, A, is equal to the sum of the two normal stresses, 70 plus 10 divided by 2, which is 40. The radius of the circle is equal to sigma x minus sigma y, which would be 70 minus 10 over 2 squared, plus tau xy, which is 40 squared, and that gives us a value of 50. Case 2, A is equal to sigma x plus sigma y over 2, that would be 120, plus 60 over 2, which is a value of 90. The radius is the square root of 120 minus 60 over 2 squared, plus tau 40 squared, same as for the previous one, and the radius of that one is also 50. So both of these circles have the same radius, both of these cases have the same radius, but the circle is shifted. And so let's look at this a little bit more closely. I'll plot Mohrs circle for case 1. Okay, here's my sigma and tau axis. I have the center of the circle located at distance 40 on the sigma axis, and then the radius is 50, so that tells me that the principal stresses are going to be 40 plus and minus 50. So there's the first one. 40 plus 50 is 90, and 40 minus 50 is negative 10. Okay, and so we'll just sketch our little circle around that. And the tau max, this is the tau max in plane, is at the top of that circle equal to the radius, and that's 50. So tau max in plane is equal to 50. Okay, for the second one, do the same thing, sketch. Now the center of our circle is way over here at 90. Okay, and the radius is 50, so that means the principal stress is 90 plus or minus 50. One of them is going to be over here at 140. The other one is going to be over here at 90 minus 50, or 40. The circle looks like this. Okay, and the maximum tau max in plane is equal to the radius is equal to 50. So I'll write tau max in plane equals 50. Okay, so because this is a plane stress state and the out-of-plane stresses are 0, we know that when we rotate to the principal axes, we have a third principal stress which will be equal to 0. So I'm going to locate that in each case. So for the case 1, my third principal stress at 0, that means I can draw two additional Mohrs circle, one that's really small and one that's slightly bigger, but both of them lie inside the existing circles. And we label our principal stresses in the order them from smallest to largest, or largest to smallest. So sigma P1 equals 90, then sigma P2 equals 0, and over here sigma P3 equals negative 10. Now our tau max in any plane equals sigma p1 minus sigma p3 over 2, which is 90 minus a negative 10 over 2, and that's equal to 50. And so that's equal to our maximum in-plane shear stress. And because this is the in-plane shear stress, makes the largest Mohrs circle. Okay, so maximum shear stress in any plane happens to occur in the plane that we were considering. Now let's look at case 2. This one is slightly different. We know that if we rotate to the principal axes, principal stresses are 140 and 40, and we don't have any shear in any plane, so a third principal stress, the out-of-plane stress, must be 0. So I'll put a third principal stress there. Therefore, I can draw two more circles connecting 0 and 40, and connecting 0 and 140. Okay? So now, if I order my principal stresses, the largest, sigma p1 equals 40, or 140. Sigma p2 equals 40, and sigma p3 equals 0. Now my maximum shear in any plane, tau max, equals sigma p1 minus sigma p3 over 2 equals 140 minus 0 over 2, which is 70. And that would be the maximum shear on this largest Mohrs circle. So up here, tau max in any plane is equal to 70. And this happens to not be in the plane that we were considering, but it's for some other orientation. Yet this is important to know if you were designing the aspect, designing this material or body, because it would be important to recognize that the maximum shear stress did not occur in the plane that you were considering, but was actually a larger value. Okay, so basically this situation arises when the Mohrs circle for the planar loading lies entirely on the positive sigma axis or on the negative sigma axis and does not include the origin. In that case, the maximum shear will occur in some other plane as it has here. All right, that concludes this example.